Welcome to this lecture on the abdominal wall. This slide lists the objectives that you should be able to answer at the conclusion of this presentation. First, list the muscles of the anterolateral and posterior abdominal walls. Describe the attachments, innervation, and action for each muscle. Describe the rectus sheath and how the arcuate line is formed. Describe the arterial supply to the abdominal wall. Describe the anatomy of the inguinal canal. Define the boundaries of the inguinal triangle. And lastly, anatomically distinguish a direct from an indirect inguinal hernia. And then we'll proceed to the summary slide and identify the important take-home messages. And then lastly, provide attribution for the images that were used throughout this presentation. We'll stop momentarily here to point you out on the body map, our area of attention or focus. Here is the anterior abdominal wall, so we'll be looking at this region of the body, outwards here laterally, and then we'll also want to take a look at the posterior abdominal wall as well. This slide depicts the muscles of the anterolateral abdominal wall. These muscles consist of 3 pairs of flat muscles, and then we have 2 pairs of vertically oriented muscles. The flat muscles are the external abdominal oblique, the internal abdominal oblique, the transversus abdominis, and then our 2 vertically oriented muscles will be the rectus abdominis and then a very small pyramidalis. And again, all these muscles listed here are paired, so we have right and left muscles. Let's take a moment to look at each one of these muscles individually. And when we do so, our interest here will be on describing the attachments of the muscles, their innervation, and their actions. So our first stop will be the external abdominal oblique. And I want to highlight the fact that we can see those fibers here. These fibers are running in the same direction as the external intercostal muscle fibers that are a part of the thoracic wall. That means they're running down and in, and they will attach to this whitish sheet that we see here, and this is the aponeurosis of the external abdominal oblique, and then that aponeurosis will course toward the midline and help to form what is known as the rectus sheath, and we see the rectus sheath right in through this particular area. The attachments of the external abdominal oblique, points of origin are going to be here more superiorly. The external abdominal oblique is going to arise from the outer surfaces of ribs 5 through 12. And then the insertion of the rectus will be to the aponeurosis, ending in the midline here, the linea alba, and also to the iliac crest. The innervation of the external abdominal oblique will be from anterior rami of the inferior 6 thoracic spinal nerves. So we're looking at anterior rami from T7 all the way down through T12. The actions of the external abdominal oblique. Let's first think about both the right and the left external abdominal obliques contracting. That will help flex the trunk of the body like so. We can also consider these working unilaterally. So if just the right external abdominal oblique contracts, it can help the body laterally flex to bend toward the same side. It can also help to rotate the torso, and for the external abdominal oblique, if it's contracting, it will rotate the right side. If it's the right one contracting, it will rotate your right anterior abdominal wall toward the left side of your body like so. In addition, the rectus abdominis, as well as the other two flat muscles of the anterolateral abdominal wall, will help to compress the abdominal viscera, as well as protect the abdominal viscera. The internal abdominal oblique lies immediately deep to your external abdominal oblique. And if we take a look at our diagram here, or illustration, the internal abdominal oblique is shown right along in through here. The cut edge of the external abdominal oblique is right along here. And now we see the fibers of the internal abdominal oblique. They are running down and out. This is the same orientation that the internal intercostal muscle fibers have within the thoracic wall. Here, more anteriorly, we can see that the muscle fibers are ending in the aponeurosis of the internal abdominal oblique, and that aponeurosis will extend toward the midline of the anterior abdominal wall and end within the linea alba, and will also contribute to the formation of the rectus sheath. The attachments of the internal abdominal oblique, more posteriorly and out of view here, would be to the thoracolumbar fascia. It also will have a point of origin from the iliac crest, and it is going to attach for its point of origin along the inguinal ligament, and the inguinal ligament is formed by the aponeurosis of the external abdominal oblique. Its insertion points will be to the inferior ribs, and we're looking at the inferior 3 or 4 ribs, so that would include 12, 11, and 10, and perhaps even rib 9. It would also insert into the linea alba, as well as to more inferior portions associated with the pubic bone. The innervation of the internal abdominal oblique will be by the anterior rami of the inferior 6 thoracic spinal nerves, T7 through T12, and it also picks up additional innervation from the anterior rami of L1, the first lumbar spinal nerve. The actions of the internal abdominal oblique, if both are contracting, both will help to flex the trunk, just like the external abdominal oblique. The internal abdominal obliques help to protect and compress the abdominal viscera, just like the external abdominal oblique. If just one side is contracting, let's say the right internal abdominal oblique, it will help to bend toward the same side or laterally flexed. And it will help rotate the anterior abdominal wall in this direction. So if it's the right one that's contracting, the right side of the anterior abdominal wall rotates toward the same side, thereby pulling the left over toward the right. The transversus abdominis muscle is the deepest flat muscle of the anterolateral abdominal wall. It is visualized over here on this side of the image. This portion that we see here, the muscle being reflected, that belongs to the internal abdominal oblique. We can see the transverse or horizontal orientation of the muscle fibers of the transversus. They end within an aponeurosis as well. This aponeurosis extends toward the midline and will also contribute to the formation of the rectus sheath. The attachments of the transversus abdominis are going to be posteriorly, so out of view here, to the thoracolumbar fascia. In addition to the iliac crest, points of attachment shared with the other two flat muscles. It will also have an attachment to the inguinal ligament, that inferior ending or termination of the external abdominal oblique, and it will also have points of origin from the costal cartilages of your inferior ribs, usually the inferiormost costal cartilages of the 6 ribs here. Its insertion will be into its aponeurosis, which extends into the linea alba, will also attach to pubic bone structures such as the pectineal line. Innervation of the transversus will be the inferior 6 spinal nerves again, T7 through T12, and their anterior rami, and it also will receive a contribution from L1. Actions of the transversus abdominis, because of the transverse or horizontal orientation of these muscle fibers, the primary function of this muscle is to compress the abdominal viscera as well as to protect the abdominal viscera.
Let's talk about what happens if an oblique strain gets injured. This happens typically when one of both obliques are overstretched or partially torn. This can be caused by flexion, lateral flexion, or twisting. A typical symptom of this injury is a sudden, sharp pain around the rib cage. This pain is exacerbated when sneezing, coughing, and deep breathing.
This slide is introducing us to the concept of the rectus sheath. The rectus sheath is a sheath that will surround or invest the rectus abdominis muscle. The rectus sheath is going to be formed by the aponeuroses of the 3 flat abdominal muscles that we just described, the external abdominal oblique, the internal abdominal oblique, as well as our transversus abdominis. The orientation of these aponeurotic components will vary depending on if we're above the umbilicus or for about halfway between the umbilicus and the pubic bones. If we take a look at some of the profiles that we have here, we have 2 profiles that are at and above the umbilicus. And then this axial section that we see in through here is at a point that's about halfway between the umbilicus and the pubic bone. If we look here at this upper portion of the figure, we see our rectus abdominis right in through here. We see that it is completely invested anteriorly and posteriorly by aponeurotic fibers. So it's completely surrounded by a rectus sheath at this point. Same thing is true with this middle axial or transverse section. Contribution to the rectus sheath is from here, the aponeurosis of the external abdominal oblique. It completely will run anterior to your rectus abdominis muscle, meet in the midline here, the area of the linea alba, and then intermix with the aponeurotic fibers from the opposite external abdominal oblique. Your internal abdominal oblique is this middle muscle layer. It has its aponeurosis beginning right about here, and the aponeurosis of the internal abdominal oblique will split. Some of the fibers will run anterior to the rectus and then meet and intermix with the opposite fibers of the internal abdominal oblique aponeurosis. And then the other half of the aponeurosis of the internal abdominal oblique will run posterior to the rectus and then intermix in the linea alba with those from the opposite side. The transversus abdominis is your deepest layer, and we see it running right along here. It too has an aponeurosis, and at this level of an axial section, all of its fibers are running posterior to the rectus, will then intermix with those from the opposite side in the area of the linea alba. Now, if we get inferior enough with our axial section, we will see a difference in the orientation of these aponeurotic fibers or sheets. And if we take a look here, here's your external abdominal oblique, internal abdominal oblique, transversus abdominis, and if we come more toward the midline, We see all the aponeurotic fibers converging here, and they will all run anterior to the rectus abdominis. So there is no longer a posterior component or contribution or lamina to the rectus sheath. It is devoid in this inferior location. Where you see a transition of the rectus sheath lying anterior and posterior to where you only have it lying anterior to the rectus abdominis, you will see an arcuate line. That arcuate line is depicted in this image, and if you remove your rectus from the view, the right rectus has been cut here, and the two ends partially reflected. Here is the rectus sheath that lies posterior to the rectus abdominis. Here is the inferior margin of where that posterior lamina ends. And then you see that it is the arcuate line that defines that termination. And then if you go below that, this area here is devoid of the posterior portion of the sheath or lamina, and all those aponeurotic fibers at this level were running anterior to your rectus abdominis. At this point below the arcuate line, the membrane that you see here belongs to the transversalis fascia. Now, the rectus abdominis muscle specifically will have attachments, will have its own innervation, as well as produce some various actions. The attachments for origin are going to be inferior, and those points of origin will include the pubic bone as well as the pubic symphysis. The points of insertion will run more superiorly, and those will include the costal cartilages of ribs 5 through 7 typically, and the midline structure being the xiphoid process. Innervation to the rectus abdominis will be by anterior rami from the inferior 6 spinal nerves, so T7 through T12, and the actions of the rectus are to help produce flexion of the trunk of the body as well as to compress abdominal viscera. This brings us to the last muscle, or last pair of muscles that belong to the anterolateral abdominal wall, and this would be the pyramidalis muscle. This is relatively unimportant functionally, and it may be absent in some individuals, but it is this very small muscle mass that we see here inferiorly located in the illustration. It lies deep to the rectus sheath and would occupy a region between the rectus abdominis muscle itself and the anterior lamina of the rectus sheath. You can see it is shaped like a pyramid. This is just the left one. You would have a right one on the opposite side as well. Attachments of this muscle are from the pubic bone and pubic symphysis, and it inserts into the linea alba, which is this region right in through here. Functionally, it is said to tense the linea alba, but again, this is relatively unimportant. Its innervation is from the anterior rami from your 12th thoracic spinal nerve.